Strato has been a premier supplier to the railroad industry for over 40 years. As we developed broader and more technical product lines, the need to develop internal technical expertise to support our product development and partner with the industry on research grew. Today, Strato has one of the largest concentrations of mechanical engineering capabilities serving the rail and transit industries. From the size and quality of staff to the facilities and equipment in Strato's 10,000 square foot lab and quality center, it is well equipped to meet the needs of our customers and the industry. Ownership's commitment starts from the overall mission to exceed the need. In engineering, this philosophy translates to a willingness to partner and contribute the expertise to developing solutions for our customers and the industry. Depth of engineering starts with our team. In terms of mechanical engineers, our 15 professionals make up one of the largest concentrations of mechanical expertise in the industry with over 200 years of experience. We support this group with senior management and professional staff with significant industry experience. Our labs are manned by trained technicians who support and execute the testing and development of product. The headquarters in Piscataway, New Jersey is where the majority of our labs and personnel are concentrated, but we also have a global presence in key North and Latin America locations and in China. Our team is also diverse in terms of native language, allowing us to communicate effectively with key vendors and customers in their native language. We are literally within hours of getting first response to understand issues that arise at key locations, be it a vendor in China or a customer in a remote North American location. Strato depth of engineering is highlighted by what surrounds the team in terms of tools, equipment, and facility. Our 10,000 square foot research lab houses a complete product development lab, including state-of-the-art equipment to test products and materials. Strato uses an extensive portfolio of tools, processes, and laboratory testing to develop and improve parts. With these, we can optimize strength and fatigue life while minimizing cost and weight. SolidWorks is our base platform for drawing. It has features to allow modeling, assembly layouts, animation, and to provide imports to more advanced tools. This also has one of the highest compatibilities with other CAD systems. We can and do exchange drawings with our vendor and customer software. For easy customer interaction, any file type can be created to exchange drawings or models within any other engineering software. One tool that uses inputs from SolidWorks is the ANSYS Structural Finite Element Analysis Package. Strato Engineering has advanced capabilities to perform product strength evaluations, fatigue analyses, and determine failure modes of current design and then optimize a new design. Strato also designs the tooling critical to casting successfully. We use FlowCast, a computational fluid dynamics package, to optimize part orientation and gating locations to ensure the elimination of voids. We also use SolidCast, a heat transfer and thermodynamics package that works in concert with FlowCast. This package provides Strato engineers the critical fraction solid time to mathematically verify riser location and eliminate shrinkage. These products are used with our vendors' toolmakers to maximize casting integrity. Modeling is a key resource in design. Our rapid prototyping machine can build a plastic model in under 24 hours, which can be taken into the field to be tested for form and fit. When designing parts to fit across a wide range of cars, this testing can be very valuable. On the left is a 3D model. A plastic prototype can be made in 24 hours for fit up from the 3D model. If desired, Strato Engineering can take the plastic prototype and have it cast in steel using an investment casting process. This allows us to make a steel sample for testing without the expense and time of permanent tooling. A sample can be available in less than 28 days. Designing a product and simulating the stress loads is only the start. Metallurgy and material properties are critical for product performance. Strato has an in-house metallurgy lab and testing facilities for heat treating and quenching. The load and abrasion tester is allowing us to test new materials that are not traditionally used in the railroad industry, but might allow us to make significant steps forward in extending product life cycles and reducing maintenance costs. An example of material testing is Strato's rotating fatigue testing equipment. With this, Strato Engineering is able to test the fatigue life of multiple test specimens before scaling up to full production on a given material. Strato has also designed numerous machines to simulate field conditions. The tension and compression tester is an example of replicating real-world conditions in the lab. It can also be coupled with a strain gauge system to validate FEA analysis. Strato also builds in-house a number of machines to address unique problems. Seen here is a seat casting that required 23 holes drilled on 16 planes. This part had problems with alignment installation until Strato designed this machine to drill all 23 holes from one fixed position. Strato embraces an engineering design discipline that incorporates the design elements of manufacturability and maintainability to provide our customers with products that can be made to a consistent quality efficiently and a product that has low incidence of failure along with a low cost of ownership and extended life. DFM squared is viable because of the overall depth of engineering at Strato. To optimize the many design elements requires true concurrent engineering capabilities, from design to build to be in place. Firms who lack these internal capabilities cannot execute in a coordinated or timely manner. While the goal is simple, optimize during the design phase manufacturing functions and detection and prevention of failure, it requires a significant set of capabilities to address and resolve each step properly. An example of what we mean having the capability to execute DFM squared is in tools to optimize the manufacturing function and precision machining. Design for manufacturability is accomplished by having design teams responsible for both product design, process selection, and machine programming. Knowledge of the manufacturing process and the ability to create fixturing and tooling in-house aids in the design process. If we did not have the ability to make tooling, fixturing, or program machines, it is unlikely we would understand the issues, and certainly even if we did, the development time would be so extended it would become dysfunctional. The bottom line is faster turnaround and a well-manufactured product. There is good reason for Strato to be a leader in the DFM squared movement. Many components used today by the railroad industry were designed in the 1950s or earlier for operating conditions that no longer represent the scope of operations today. The past emphasis has been on lowering cost more than on improving performance, but that time is now past. Cost of ownership is expanding to look at the cost of in-service failures and extended life. Design models have to evolve past cost focus. The operating environment of today and future plans that include longer trains, heavier loads, and faster speeds are showing that those designs are not as robust and reliable as the industry needs. One industry leader measured component failure of trains 10,000 feet and longer and found they are 3 to 4 times more likely. Regulation is also playing a role in stricter requirements. Designing the maintainability will lower the ownership costs of our products and our customers' assets. More importantly, it must reduce the rate of in-service failures and reduce train delays and catastrophic failures. To design parts to meet tomorrow's needs, Strato is building a new generation of test equipment for testing critical components in any way necessary. The Hercules Ultimate Failure and Fatigue Tester will play an important role in DFM design and evaluation of our products and our customers' evaluations. Hercules will have the ability to do tension and fatigue testing far greater than available today on draft system components, truck components, rollover protection, and other safety components at levels current operating and future conditions will experience. This will help us identify design, material, or process issues that will cause unacceptable reliability or life requirements. Strato is dedicated to making safe, effective, and extended life components for cars and locomotives. To ensure that we meet the mission of our company, exceed the need, we will continue to expand our resources and increase our capabilities to serve the industry and our customers.